Hello folks, this is 2005 May-June paper 1 and the question number is 13. This question is concerned with the chapter forces here, so which includes moment, torque, etc. So an L-shaped rigid lever arm is pivoted at point P. So we have a L-shaped rigid thing made of metals probably, and it's pivoted at point B. So point is fixed and all other things can move. And it's rigid here. So let me remind that it can't become straight like this. So it just both of them move together like this. So three forces act on the lever arm. Three forces: 10 Newton, 5 Newton, and 20 Newton. And all the distances are given here. What's the magnitude of the resultant moment of these forces about point P? So find the resultant moment. One thing that I can remind all the viewers that this thing represents the arm of a person. The arm of a person. This is the shoulder. This is elbow, and this is the palm or wrist area. So it's about multiple forces acting on the arms. So you can just make a visualization there. So I have to find the resultant moment. So first of all, let us identify which forces cause clockwise and which forces cause anti-clockwise moment or torque. So let's see. This 5 Newton. If I put the point fix here, this 5 Newton will try to lift this thing. So if I lift this thing will try to come like this, somewhat in this manner. So this force gives us anti-clockwise moment. So in tau anti-clockwise, this thing contributes. So I must have this force. This force is of 5 Newton. 5 Newton into. Let me produce this. So this is the line of action of this 5 Newton, and the distance. This thing is equal to the distance from a pivot till this is equal to this distance, and this distance is equal to this distance. So this distance is equal to this whole thing is 4 meter minus 2 meter. So this is equal to 2 meters. So that means this is 2 meter. So it's equal to 2 meter. So this force produces anti-clockwise moment on this thing. Then I have got this 10 Newton. So what I mean is, if I put force like this, if this is the fixed point, then this thing will try to rotate like this, somewhat like this. So this also causes anti-clockwise moment or torque. So that's why I must add it here. Plus it is a 10 Newton into. So this is the line of action. This is the line of action of this 10 Newton force, and the distance of this line from this pivot is 2 meters. So distance of this pivot from the line of action or vice versa is 2 meters. So it's equal to 2. So this becomes 5 2s are 10, 10 2s are 20, 10 plus 20 is equal to 30 Newton meter, and it is anti-clockwise. So it is anti-clockwise. So let me repeat again. So this 5 Newton causes, if it is fixed point, it causes this thing to lift like this, and this causes it to go sideways somewhat like this, because this is fixed. So all anti-clockwise. Then comes this force, 20 Newton. So what happens is, if this is fixed point, this thing will cause it to descend. So you can just imagine yourself holding something in your hands, some load here. This is the fixed point here, this elbow. So the hands will definitely come down. So come down like this. So this causes clockwise moment or torque. So tau clockwise should be equal to this is 20 into this distance. The distance is from here till here. So this one from here to here, and here to here is same. So it's equal to 3. That's equal to 60 Newton meter, and it is clockwise. Now we have got two torques here. One is clockwise 60, one is anti-clockwise 30. So we must have the resultant moment or torque is equal to tau clockwise minus tau anti-clockwise. That gives me 60 minus 30 equal to 30 Newton meter, and that is ultimately clockwise. So clockwise wins. That means this thing will slightly rotate like this, or it might, if I consider it is vertical, it will come down. So the answer to this question becomes choice number A. All others disqualify.